everyone, my name is Dana Daly and I am the IEEE Educational Outreach Director.
Hello everybody, my name is Christopher Wall and I'm the IEEE President.
And we're from the IEEE Student Branch at the Cullen College of Engineering.
Today, we're here to talk to you about a homopolar motor, a very fundamental electric motor.
Before we get started making our homopolar motor, we'll first go over the materials we'll need and some safety guidelines. The first item we're going to need is some pliers in order to manipulate our wire. The second item is a wire cutter. The third item is the type of wire we're going to use, which is 18 gauge uninsulated copper wire. The fourth item is a AA battery. And the fifth item is a neodymium magnet, which looks like this. Next, let's go over some safety guidelines. First things first, and most importantly, do this experiment with parental supervision. Because we are using electricity and wire cutters, this is very important. Next item, don't leave the motor on for too long. Because we are using fairly high current, we don't want the battery to get hot. Third item, don't cut yourself. Be very careful with the wire cutters while you're using them. And last, do this experiment in a dry environment because we are using electricity. Now let's make our homopolar motor. It's time to build our homopolar motor. First thing we want to do is cut our copper wire to the proper length. We want to cut a piece about 22 centimeters long. So I'm just going to measure out 22 centimeters, take my wire cutters, and being very careful, I'm going to cut my wire. Now I have my piece of wire about 22 centimeters long. Next thing I want to do is bend it into shape. So I'm going to take my pliers, and first I want to bend it into a V shape right in the middle. So you want it to look something like this. Then when you have it in this shape, you want to bend both sides back down. Once your wire is in this shape, it's time to make the legs. This little point at the top is used to put on the positive terminal of the battery, which is why you want it to be shaped like this, so that the wire can easily spin. So now we want to take our pliers again and bend the wire legs like so in either direction. And you want to make sure that this long side is long enough to reach from the positive terminal of the battery to the negative terminal of the battery. And you want to make sure your legs are curved enough so that they can hug the magnet that is at the bottom of the battery tightly. Now, it may take some adjustment to get your wire exactly how you want it. So for the purposes of our demonstration, we want to show you an already built homopolar motor. So you can see at the bottom, we have our magnet. And if we just take our wire and rest the point on the positive terminal, make sure that our legs at the bottom are hugging the magnet correctly. You may have to give it a little push and it'll spin. It may take some adjusting. There we go. And there's your homopolar motor.
Okay guys, now that we've seen the motor in action, let's look at the theory behind it. So here in my diagram, I have our battery, I have a wire going from the positive terminal down to the negative terminal, and I have our magnet. When we hook up our wire, we're going to get a positive current flow in this direction. Simultaneously, our magnet is going to give off a magnetic field. However, the direction of our magnetic field depends on whether we have the north end or the south end touch the negative terminal. In this case, we have the north end, and that gives us a magnetic field in this direction. Now, why does this cause a force? Let's take a look. Way back when, we discovered the Lorentz force. The Lorentz force tells us if you have a current going in this direction, magnetic field going in this direction, we're going to get a force in this direction. This is our right-hand rule. Let's use right-hand rule on our diagram. So here, our current's going in this direction. So I'm going to line up my thumb. Our magnetic field's going downward. I'm going to line up my magnetic field. That's going to give us a force toward the camera. And this is going to cause our wire to go clockwise. Now, what if we flipped our magnet so now the south end was touching the negative terminal? That would also flip our magnetic field to go in this direction. So we take our right-hand rule, flip our magnetic field finger, we see now the force is going into the whiteboard, and that would cause a counterclockwise spin.
Thank you so much for watching our video. If you want to see more IEEE educational outreach videos, go to our YouTube channel at the link here. If you want to see other educational outreach materials or learn more about our organization, go to our website at the link here. From all of us at the IEEE student branch at the Cullen College of Engineering, we thank you so much for watching. See you next time.